This is an Atlas 7 head, fluid head. It gets its name, the 7 part comes from our original fluid 7 head, F7 head, as it's been known for 43 years or something like 41 years since we first made the very first unit that was originally made for the Eclair NPR camera, which was a very tall base to lens center height. It works on the principle of half a gimbal. You can see like this. It doesn't need a counterbalance in it, because what you're going to do is balance the mass of the camera on the pivot point of the tilt. Okay, I'll show you it in its narrowest mode at the moment. This is going to take most of the current cameras on the market, i.e. Red, Sony F55, Alexa, most of those things. Some of the earlier film cameras you may have needed to make it wider. Has the same dovetail system for the slide as the other Atlas heads. So you have the Arri dovetail slide here. Again, this slides it on from the front, from the back, whichever way round you wish. And also the quick release version as well, so we can use that the same. To actually fit a larger camera on this, we just have to undo this screw, make that click, and I'll turn this round so you can see the safety. The safety is here. Pull the safety out. The platform has to come all this way before it will come forward. So it's relatively safe for about 60% of its life. So the first block I'm going to put in, this is an 8 centimetre wide block. You push the safety away. You hear that click in. That's gone in safe. Up to there. Push the second one in. Again safe. Up to there. And tighten both of the screws up. So you now see we have a much wider gap here for larger cameras. On a standard kit, 3 of these blocks come with it. So obviously we've now moved that centre off. We fit another block in here to move the side this way, and we can fit another block in here to make it taller. There are 3 sizes of this block. 8 centimetres, 16 centimetres, and we do a 4 centimetre one as well, which I don't have here at the moment. But they're all designed specifically to do certain jobs. I'll put this back as it was. Again, very simple. Undo the knob, click, safety. That comes off. Undo the next knob. Safety, pull the block off, put the original platform back on. The principle of everything on here is very similar to the Atlas 30 that we just did. Same locking assembly on this side, same safety lever, which pulls this out of the slot. And when the plates go on, when you hear them click, that's safe. Can't come off of either end until you pull that safety out. And again, they go on from front or back. Now, this dovetail is also shared with this part here. I'll tilt this up so that you can see the shape of the dovetail here. It's exactly the same. So in the current situation where we are, very popular, certainly in the UK at the moment, is to take the camera off and shoot the traditional way in landscape. Remove that, put the camera back on, and we're now shooting portrait. Literally, I don't know, 20 seconds or something like that. Not so easy with the camera on, but nevertheless, we now have the camera on its side and shooting portrait. Of course, it shares its original concept of balance backwards and forwards. Although we can't move anything up and down, it's usually close enough in balance in its side-to-side mode when it's on there without having to raise or lower it. The fluid units on these are actually identical as far as the machining is concerned. There is a difference in that this has a rosette on the top and the one on the pan has a spirit level. There are 15 stages of fluid on this, unlike the Atlas 30 and Atlas 40. It also has a 0 at both ends. so you have plenty of options there with that. We use exactly the same pan bar, also rosette mounted in the centre, with its adjustment to wherever you need it, and also telescopic. So there's plenty of adjustment on there. Okay, in the back end, the top here, you can see, and I will raise this up, this has 10 millimetre steps, and this is a safety device on the side of this, which you lift out to allow the head to go down. Okay, when you go into third axis, we have an option on the back here, which gives us 12 millimetres of movement on here. Sometimes you can do by finger, but sometimes by Allen key. So this gives us a fine adjustment on here when we want to go third axis and spin on the lens itself. Now we can go 3 axis on this head. I don't have the parts, but I can explain it. Basically, this plate here is much longer, which fetches us way back to this position. And we then put another tilt fluid unit on the side of it. And then what happens is we have the camera, which is now going to revolve here. So we have a dovetail plate 2-way. We have a target plate on here, which is very bright red with a cross in it. You take your camera, take the lens out, put a lens port cap with a pointer on it. So you're now putting the camera facing this way, and let's assume that my little finger is the actual centre. You come down here, you raise the unit up and go across central, reverse the camera, put the lens in, and you know that will then spin on that axis. Now when we use a 3 axis, we take the pan bar off, and put a sports car steering wheel on there, which enables you to roll the head and tilt and pan all off of that unit. All over this head there are different tapped holes. There's 3/8 tapped holes, 1, 2, 3, 4 on this part. There's quarter tapped holes on here. There's another quarter hole in the top. They will all take a monitor. So if you imagine that I'm operating this from behind, I can have the monitor sitting out directly in front of me while I'm rolling the tilt. And that's basically how that works. Always the problem when you go 3 axis is the camera will never balance properly. So on the top of this plate, there are 3/8 tapped holes. And on the bottom, there are 3/8 tapped holes on both the short version and the long version. So we can then screw in 19mm bars and put weights on it. So you can counterbalance it if it's back heavy, put the weights on the front, and vice versa, and the same with the roll mode. Obviously, depending on the camera and whether you want to do a 360 roll, depends on how many blocks you need in it so that the camera will completely roll. Unfortunately, I can't show you much more than that, but I can explain it, and we have stills to insert into that. So that's that basic side of it. Now this head, as I say, derives from the F7. The biggest 2-axis F7 weighs 11 kilos. Cartoni came along with a Lambda which weighs 21 kilos, and most people complained about the weight of it, although it was very quick to adjust. So our brief building this was to try and get this to 14 kilos. We didn't quite make it. It's 15 kilos as you see here now, so it's still 6 kilos lighter than the Lambda. As you saw when I took this off, it's very quick to move things around, very quick to make any adjustments on it, quick to change and put the blocks in. The advantage of having the blocks is it becomes very rigid. You don't get the sag when the camera is sitting on here, which you would with, as per original, large film cameras that are maybe 40 kilos in weight. So we don't have that sagging problem on there at all. This handle on the top is also useful because you can carry it with that. You take the head off and carry it by your side. This is very unusual in the fact that this will 360-degree tilt, and you can also use it as a 4th axis. So I'll build it up in that stage at the moment. Let's by taking some of the parts away rather than having lots of weight on it. Again, the fluid unit is exactly the same as the other platform. Undo the screw until it's loose. Push the safety. There's your fluid unit complete on its own. I'm now going to take what is obviously a J plate, just because of its shape. I'm taking the J plate off from there and I'm going to rotate it 90 degrees and put it back on. It now comes in that position. Put the fluid unit back on from the underneath. Drop the sliding plate and the camera platform in. Make a reasonable adjustment on the height of that. Remount your camera. And you can now, without using a pan bar, 360 degree tilt this head. Show you that way round so that you can see it that way. So you can 360 tilt this. Okay, there is also a fourth axis of which we do have a clip. By removing this, and as per the portrait, you mount your camera like so. If you're looking over the top of a building, so quite a tall building down to the pavement below, and your subject is not immediately below with an over the top head, the only thing you can do is pan the head and you lose your horizon. With this you don't have a problem. Normally with an over the top head, if your subject is not immediately below you, the only thing you can do is pan to bring the subject in. Whereas this, you just keep this square, you pick up the subject here, the subject may be walking along the pavement, you can follow them along the pavement all the way around and you can 360 this. So we can go up the side of the building, across the ceiling, down the other side and back to where they started. This is the same specification materials and finish that we use on all of the Atlas heads. So it's high tensile aircraft standard 6082 T6 aluminium, stainless steel fittings inside, slide plates are aluminium. Anything that needs safety devices on it is red. The locking mechanism in here and the safeties in here and the brake are all 303 stainless steel. There are acetal parts inside which you can see. The back end of the friction is the white area inside there. And that friction is built into a stainless steel 303 housing which the bearings fit on, two very thin section bearings, and the brake works from. So again, this is sealed inside here, as it would be here and here, and in the back. And that's exactly the same as the pan. The only difference between the two units, apart from the spirit level, this plate is held on with those 8 screws. If you take that plate off, you can then put a Mitchell base on. It is possible to put a ball on this, but we don't like it. It's a very big head to be on a ball, because if you undo that knob, bang, it's going to go over very quickly because of the mass being to one side. So it's not like undoing a normal over-the-top head, which in theory should stay still until you decide to move it. But because this has got offset weight, it will fly away. And there could be fingers missing. Most of the parts in this are hard anodized as well. The brake assembly on here works very similar to a car brake. And it pulls equally around the centre so that when you put the brake on, you don't get a nodding effect, because it must come on equally either side of the centre, when actually they pivot from this end and are pulled in to wrap around the stainless steel drum. So there's hard anodised aluminium brake segments, rather like the old-fashioned car brake shoes, that clamp onto the stainless steel drum. And that drum is the main central fixing, which this has got the shaft going through and comes on this to the rosette on this side and through to this 5-star plate on the other side, which is the drive unit off of the friction itself. There are actually places on here, there are quarter tapped holes in the base here and in the what would technically be the side. If you did want to mount something in there, i.e. you want to mount a box, you could put a bracket in there and put a box on there. It has been mooted that we electrify it and make it as a remote head. So that would be ideal space because there's a lot of room in there. You can see there's a whole load of room in those places. It's hollowed out for its strength and loss of weight, and it's cross-braced in both of these. So there are places where you can attach things. One thing I didn't give you, on this side of the pan, there's an eyepiece leveling bracket which takes a 16mm tube which will come up to your eyepiece here, and that just bolts on using these 2 screws.